All right, it says. Says if the supply function for a commodity is given by that equation and the demand function is given by the other one, find the equilibrium. So you have to help me out, because I can't remember, because you know me. So flip back a page. So if I have this, and that's our. This is our supply. This is for problem number 1. And our demand is this, which is this equation here. P equals negative 20Q plus 2,500. All right. On the page before, look at the graph. Is the vertical the X or the Y? It's Y. So is that P right there? Yeah, P. So P is the Y. So P equals Y. And then Q equals X. That way I can plug it in to Desmos, because Desmos doesn't do P's and Q's as far as I know. I might be wrong though. So Y equals X squared plus 100, and then Y equals negative 20 X plus 2,500. And we want to find the market equilibrium. That's basically where the two of them cross. All right. Desmos, where's it at? Not here. So Y equals X squared plus 100. And then Y equals negative 20Q or 20X plus 2,500. Is that right? Cool. So then we have to kind of search for the graph. So, oh, we got a quadratic there. Okay. Where are these guys going to intersect? Ooh, about up there. All right. So the market equilibrium on this one, we don't want to see the negative. So I realize it's a parabola versus a line, meaning the line is going to cross it twice. But I think 40, 1700 is the ideal one. If you went up here and you found this market equilibrium here, this wouldn't make sense because it'd be like negative 60, 3700. So we're not looking for the negative value. So we're just looking for the positive value that it would take on. So 40, 1700. That makes sense. And again, where they have the X is 0 to 80 and the Y is 0 to 3000. That's really if we were using the Texas Instruments graphing calculators to get you set your window up to do that. But this will work if we do it on Desmos as well. All right, if the demand function for this, do what? If the demand function for a sale of widgets is given by P parentheses Q plus 4 equals 400, and the function is given to be 2P minus Q minus 38 equals 0, find the market equilibrium point. Okay, so this is kind of nice how this one's set up, because Desmos will handle it no problem. So we said P is Y, Q is X, and then they told us that we have 2Y minus X minus 38 equals 0. Okay, and we can plug. The nice thing is Desmos will allow me to plug it in like that. If we were using the graphing calculator, we would have to divide both sides by X plus 4 to graph it in the first one, and then move everything over and divide by 2 on the second one. But Desmos will handle many various ways of doing these, which is kind of nice. So let's get rid of this and this. So Y and then X plus 4 equals 400. And then 2Y minus x minus 38 equals 0. So both of these are going to exist on Desmos. Ooh, what's going on with the green graph? What did I mess up there? Oh, there we go. That's what I was like, why is it just the axes? All right, so it intersects two places. I'm going to take the intersection that's taking place where I have positive values. So at 12, 25, I would ignore this. And this is, again, if you look at how they have the domain and range set up below, it's 0 to 20 and 0 to 100. That would make sense for only the one. So just, this is our market equilibrium, 12, 25. Okay, we good so far? I'm going to move the book up so I can actually see it. Well, thank you. Go. That's the last problem. There's only 3 problems on the page. Thanks, I have my back. All right. Then it says, suppose that in a monopoly market, the total cost per week of producing high-tech widgets is given by the cost equation, C at x equals 3,600 plus 100x plus 2x squared. And suppose further that the weekly demand for the function of the price P equals 500 minus 2x. Okay, find the number of units to break down for each product. What would the selling price of each widget be to break even? Okay. I think we can. All right, so the first equation, C at x, so I'm going to go y equals 3,600 plus 100x plus 2x squared. Okay, so we got to find where that's going to, that's happening way up there. Cool. And then the other one, the other equation is going to be y equals, even though it says p, it would be y equals 500 minus 2x. Ooh. Okay. I plug that in right. 3,600 plus 100x plus 2x squared. 500 minus 2x. All right. Let me see if I can find this problem in the book. Where did we make a mistake here? Find the number of units, break even. I can't find a break even at this point because my graphs will not intersect each other. Okay, we have a parabola that does not intersect the line.
Is that just not, is that like an equation?
Yeah, we're taking a look. In this situation, it is, but let me think about how I would want to approach that. Suppose a monopoly market, the cost per week of producing high-tech widgets is given by that equation. Suppose that further weekly demand function for price of the product is that. Find the number. I don't think this problem can be worked out. Because I'm not, it doesn't give me a revenue equation. So I couldn't. Yeah, I don't think number 3 can be done. How'd you do it? On Desmos? Oh. Did you Google it?
Yeah, basically. It said it didn't give a direct answer. It said 10 or 90. It doesn't even know.
10 or 90? All right, am I missing something wrong with this graph? I mean, this is, so that line does not intersect. So 10 or 90. All right, I'm going to try one thing. So you're claiming 10 or 90 is what you found. I like this. Let me write this equation down so we get. So we're going to get y equals 3600 plus 100x plus 2x squared. And then they're giving us y equals 500 minus 2x. So if I set these equal to each other, I don't think the math is going to work. I'm going to go 3600 plus 100x plus 2x squared equals 500 minus 2x. So then if I go 3600 minus 2x, so I get plus 102x. I have to subtract the 500 from this, so that's 3100. 102x plus 2x squared. All right, 31, 102. Okay. Y equals 3100. Plus 102x plus 102x plus 2x squared. Is that right? Ooh. Nope, because that's not even the vertex. Unless I'm forgetting something, is there an equation you guys want to go with on this? Price of this product.
I think we should all just eat Chick-fil-A.
Yeah, baby. This lemonade's pretty good. All right, let me try one more way. So let's try this. Y equals 3600 plus 100, and I'm going to substitute in 500 minus 2x plus 2x, or 500 minus 2x, quantity squared. And get that gone, gone, gone. I am not getting anything that I would want to do. I just played with everything. This might be a problem that I gotta do some further research on. As of right now, I don't know how to do it. I tried all my tricks in the trade. I'm sorry, I failed you guys. I got it. Bless you. But that gets you to 9 and the 10, right? And that, and I bet you know that might be a typo on Brooke's part. I bet you that might be the way to go. All right. Let's forget about number 3. Sorry. I know you guys are upset by this. So suppose that a company has fixed costs of $28,000, variable cost per unit of 2/5 X plus $222, where X is the total number of units produced. Suppose further that the selling price its product is $12.50 minus 3/5 X dollars per unit. Okay. All right, so this is going to be one that we're going to look back. Let's make sure we get everything written in the right spots. All right, so we have fixed costs of 28,000. We have variable costs of 2/5 X plus 222. And then X is the total numbers produced, selling price, and then the selling price is equal to 1250 minus 3/5 X. All right. Let's make sure we have the definitions down. All right. So we have fixed costs, FC, we have that. So variable costs. So cost is variable cost plus fixed costs. So I need to add these together. So that's going to just give me the actual cost. Will be 2/5 X plus 2822. And then the other one was the selling price. Okay, so selling price we have right there. So I think if we graph these two, we might have something. Get rid of this. So y equals 1250 minus 3/5 X. Got a line, that's always good. Y equals 2/5 X plus 2822. 222. Friends, I want a loss.
Good, sir?
I don't think so. Well, one, I got a negative answer. So I'm not going to produce negative units to get a cost of $17,433.20.
Must have been a typo in this book.
It could be. I got to look these up.
Maybe
And then-
we should just take a mental break.
Yeah, I'll tell you what. We're going to just turn the page. All right. These are like got dumb on us. All right. So let's see. Worksheet 2.3. Let me just take a look on this real quick. Just make sure we're up. Here's one too. Oh, I didn't sign it. All right. So my thought is, let's see. Sorry about those 3 problems being out the chart. Definitely this one. Don't worry about the sketch. You can actually just do it on Desmos. So why don't you take a look at worksheet 2.3 and take a look at 1 through 5. I'm happy to help you on those. I'm so sorry that those last ones got goofy. Let's see, anybody?
It's up there.
What?
Up there.
Good. So, take a look at this worksheet 2.3, see if you can get that. Let's hope. And I'm going to research these last two problems, see what we had done, because there are definitely errors taking place. Might be the errors in Stirrup's brain, which is very possible. That's right.